Good evening, Algebra 2. Thank you so much for all your hard work in this first chapter. We're going to go ahead and knock out this review so that you guys can study. Please take my advice on reviewing this first part. This is the best way to study, is just kind of basic vocab and actions. So if I ask you to solve, you know there's 4 different methods. If I use 4 different words to describe those solutions or roots or intercepts or zeros, you know what I'm talking about. Really study that discriminant, like if it's positive, you get 2 real. If it's negative, you get 2 imaginary. If you get exactly 0, you get 1 real. And that's not solving it. That's only figuring out how many solutions you have. Okay? Review this as much as you can. Okay? Don't stress out about that part. I remember having that when I was in school. It was kind of difficult, but after a little bit of practice, you got it. Okay? And I'll review you guys tomorrow if you have any questions. So let's jump into complex number review. Remember that anytime you're trying to square root a negative number, it's imaginary. So if that number is a perfect square, go ahead and change it. 4i. So now I'm seeing 2 doesn't really match anything, but 4 plus 3i, that's making 7i, and you're done. So that doesn't have to be difficult, but it does need to be something that you're familiar with. So I mentioned today in class that we needed to go ahead and think about this as multiplying times itself 2 different times. You can't distribute a power like that. So we're going to multiply 2 times 2, 4, sorry, and 2 times 4i, that's 8i. 4i times 2, another 8i. And then this last one, you're getting 16i squared. So I had a few students that I can kind of pick up on our activity today. They really didn't know what to do with this thing. So let's start off with what you probably know in the middle. 8i plus 8i, that is 16i. But this right here is 16 times the value of negative 1. If you remember on this other slide, I squared equals the value of negative 1. So this is kind of one of those commonly forgotten things in Algebra 2. So when you remember that 16 times I squared is the same as 16 times negative 1, that means that value is really a negative 16. And then we can say, well, 4 minus 16 is negative 12. Okay? So watch out for that. That can be a little tricky. All right, something a little easier. We're subtracting like terms. So this can be difficult if you're not good with minus and minus or picking up on stuff like that. So maybe I'll take a moment just to kind of change my signs. Negative times a positive, that's really negative, okay? So I can kind of turn it into an addition problem like number 4, which is easier because you're not having to deal with signs as much in terms of changing them. So now I'm seeing we've got negative 4 plus 7, that is 3. 2i minus 3i, negative 1i, or just minus I, that's the same thing. And that one's done. Adding, a little easier. 5 plus negative 8, negative 3. 4 plus negative 4, well, those are really canceling out, so I think this one's, all it is negative 3. Don't have to worry about any I in that at all. Okay, again, discriminant. This right here is talking about the discriminant. It says determine the number of solutions and what type they are. So again, in parentheses, it's kind of leading you to what you should be answering that with. 2 real solutions, 2 imaginary solutions, or possibly just 1 real solution. And with that 1 real solution, why it says repeated is it's a quadratic. So all quadratics, if it has a solutions, there's 2 of them. Sometimes it's the same number, so it's like 3 for both of them. We're going to jump into that really more later. But let's go ahead and try the discriminant on b squared minus 4ac minus 4 times 8 times 1. So again, we want to know if this is coming out to be a positive, it would be 2 real. Is it coming out to be negative? Because that'd be 2 imaginary solutions, or in Algebra 1, you knew that as no solution. And if it comes out to equal exactly 0, that means you have 1 real solution. So let's kind of see what we got here. We have negative 5 squared. That is 25. Not negative 25, positive 25. Negative times a positive is a negative. And 4 times 8 is 32. Multiplying that by 1 is not going to change anything. 25 minus 32 is negative 7. So negative 7 is the discriminant. Okay, that tells us that, looking up here, that tells us that I do have 2 imaginary solutions for this particular answer. Okay, let's add 2 over to get this one started, because you do not want to do this unless you have equals 0. When you're doing the discriminant, just like the quadratic formula, you got to have equals 0, or you're technically doing like a different problem altogether. So we're going to say negative 8 squared, that's b squared, minus 4ac. So let's kind of see what that looks like. 64. A negative times a positive is a negative. 4 times 8 is 32. And 32 times 2 is 64. So it looks like I'm getting 0. And so that means that my solution is exactly 1 real solution. Okay, the solution's not 0. We don't know what the solution is. We could solve it using the quadratic formula or something. There's only 1 real solution to this problem. Let's talk about 3 of the methods that you really do need to understand before tomorrow. It says solve by the indicated method. And leave your answers in simplest radical form. Okay, this can be difficult for students that really like hold on to the calculator as tight as possible and they want to round decimals. So let's kind of look at that when it comes up. So let's start here. It looks like this whole left side is being squared. There's nothing really to move around. I need to start by square rooting both sides. Square rooting the left gives me x plus 3. Square rooting the right gives me plus or minus, like positive or negative, 4i. So now to solve for x, I'm just going to subtract 3. And so over here, I'm going to put my answer at x equals negative 3 plus or minus 4i. It's done. That is what I mean by an exact answer. I'm not trying to put that in the calculator. That is an exact answer. And that's not a radical form, but that is an answer. So let's try this one. I'll make sure I can see the problem well. We need to get everything on one side, and it looks like we need to factor it. So you need to really understand that tomorrow I may not tell you how to solve each one. You just need to know to look for these possibilities. So I am undoing my sides over there by subtracting 2x from 10x. I'm adding 2 to get 12. So now I'm thinking what multiplies to be 12 but adds to be 8, and those numbers are 6 and 2. Now I had some people, like, they were thinking about factoring so much during our activity that this is what they put as like their answer. Okay, you haven't solved it. I mean, you factored it, but you ain't telling me what made it 0. So there's one more step. X plus 6 equals 0. X plus 2 equals 0. And now what we need to do, let's scroll down a little bit so I can get some room here. Subtracting 6 to the other side, it's negative 6 plus 6 that makes 0. And I'll actually show this one moving. I didn't do that with 6, but that's the motion that we're talking about. So let's have 2 solutions, negative 6 and negative 2. So for that one, we didn't really have any radical form as well, because when you're factoring to solve, you don't really use square rooting. So maybe that's going to happen in the quadratic formula. Let's start by getting equal 0, a very important part of any solving quadratics problem. Unless you're square rooting, that's the one that you don't need that for. Okay, so let's jump into the quadratic formula. I'm going to go ahead and take time to say, okay, A is 2, B is this negative 1 that I'm seeing, and C is negative 5. So make sure that you use the signs correctly, especially C. Some people will miscalculate the discriminant because they would, like maybe in this problem, just put 5 in instead of negative 5. So watch out for that. So negative B. Negative B is already negative 1, so negative, negative, positive 1. Now we've got that negative 1 squared. 4 times 2 times, and this is what I just talked about, negative 5, all divided by 2a, 2 times 2. So let's get some room there. Let's kind of calculate what we got going on inside this square root. We call that the discriminant. Hitting y'all hard with that word here. So this is really 1. Negative 1 squared is 1. Maybe I'll have just like some middle math up here. Negative times a negative is a positive. 4 times 2 is 8, and 8 times 5 is 40. So see, this is what I'm talking about. You're getting a non-perfect square, square root of 41. 2 times 2, 4. Now I'm thinking about the 41, and I can just show you real quick. If I bring up a calculator and say 41 divided by 25, it's not going in perfectly. 41 divided by 16. 41 divided by 9. And if you notice, none of these perfect squares are factors of 41. So that's good, because that means that this is your answer. So in the directions, when it talks about leave it in simplest radical form, that's what it's talking about. Not having to feel like I have to estimate that in the calculator. Number 1 and 2, we're going to start by setting them equal to each other. Okay. I'm going to try to get everything on one side, and I really like getting this one to be positive. Okay, so that doesn't have a like turn. Let's add 10x over here. That's giving you 8x. Let's subtract 23, and that gives you negative 20. And so we want to probably think about factoring for that. So I'm going to let you kind of finish that one, see what you can do on that. Kind of getting this one started. I'm going to check my time. Okay, I got 3 minutes left. 2x squared. Again, that one's not finished. See if you can finish that one off so you have something to kind of look at home independently. Setting these equal right now. Once I have them equal, I'm going to try to get them all on one side. And I'm trying to get my quadratic part to be a positive. So I didn't subtract 2. I'm subtracting the 1x squared intentionally there. Let's subtract 3x. That makes positive 7. Let's subtract 2 to make 12. And honestly, I think I'll let you try this one as well. It's just factorable. Think about what multiplies to be 12. Let me get some room here so you can kind of study what I'm talking about. What multiplies to be 12 and then adds to be 7. Same thing over here. Multiplies to be negative 20, adds to be 8. But there's one more step. Make sure you figure out what makes that 0 to really finish those problems off. Last part. I put these in yellow and green so you can really see visually the a plus bi part. Okay, the negative 2x goes with 10, so I want to solve by setting those equal to each other, and I get x equals negative 5. For the other part, it looks like 3yi equals negative 12i. First of all, the I can cancel, because they're the same on both sides. And the last thing I need to do is divide like I did on the other one to see that you're getting negative 4. Y equals negative. Alright, I'm pretty sure I'm going to run through this real quick. I would probably think about factoring this, because you're trying to think of what would multiply and add, and that's going to be 6 and 2. 6 plus 2 is 8. 6 times 2 is 12, so make those 0, and you're looking at two negative values, negative 6 and negative 2. This one I'd probably think about using the quadratic formula, and I'm only thinking that because I've got a 2x squared there. That's why I'm avoiding that. Not really sure how I'm going to factor that, because I don't know what would multiply to be negative 3 and add to be 6, so I'm going to say the same thing. Let's do quadratic formula. And this one, I think it'd be best to think about square rooting, because I can start by dividing by 3 to get 16, and then I can start square rooting. Good luck, guys. I hope you guys do well. Hope you make it to the game tonight. I hope we win, of course. I'll see you guys tomorrow. Peace.